friends, welcome back for another beautiful deep learning project, mushrooms classification. Here we will classify the mushrooms into two categories. One is poisonous, another is edible. That is whether the mushroom is poisonous or edible based on several features posed by the mushroom. So to do this, I have imported several libraries like NumPy, Matplotlib, Seaborn, TensorFlow, keras, pandas, and from keras I have also imported layers and feature space, and from TensorFlow I have imported max.csv dataset. NumPy is for numerical calculation, Matplotlib and Seaborn for data visualization, TensorFlow and keras for making and building the model, pandas for data manipulation. So from layers module we will create the layers of the neural network that we are going to build, and max.csv dataset will be used to create a TensorFlow dataset directly from a CSV file, and feature space is used to transform the raw data into encoded format. So let's run this cell and import all the libraries. After that, using the read CSV method of pandas library, I am getting a CSV file mushroom.csv into data frame and saving that in the variable df. To see the first 5 rows or samples of the data frame, I am applying head method to the data frame. So here you can see we have these columns and these are the 5 rows. Let's see what are the properties posing by the data frame. At first I am going for the shape of the data frame. So to see the shape, apply the attribute shape to the data frame variable. Here it returned 8124,23. That means we have 8124 samples and 23 features. Then to see the column names, we have to apply the attribute columns to the data frame variable. So these are the column names that the data frame has. Then to get the more information related to the data frame, I have applied info method to the data frame. It will return the number of samples, the index starting point and ending point, the columns and number of non-null values of the columns, and also the d type of the columns. So here you can see the range index start from 0 to 8123, and you can see we don't have any null values, and all the d types are categorical type, that is object type. After that I am going for exploratory data analysis. In exploratory data analysis we will visualize the data and get the important insights from the data. So as we have all the categorical columns of object type, so I'm going with only one plot, that is pie plot or pie chart. So I'm plotting pie chart of all the columns. So to plot pie chart of all the columns, I am creating number of subplots, and in each subplot I am plotting a pie chart of a column. So to do that, I am taking number of columns to be 3, that is the pie charts will come in only 3 columns, and the number of rows is equal to this value, that is ceiling value of the value which we get when we divide the number of columns by number of calls, and I'm converting that to integer 64 d type. Then I'm creating the subplots with this figure size and then giving 0.3 units of space between each subplot in horizontally and vertically. After that, I am iterating over all the columns and creating a value count dictionary of the column and saving that in the variable value count dictionary. Then selecting one subplot for each column, then plotting the pie chart for that column. So in value count dictionary we will have counts of unique elements present in the column as values and the unique element names as keys. So I am providing inside the pie chart function values as x and keys as labels, and then I am setting auto PCT equal to lambda x, and this statement is a conditional function where if the percentage value of a unique element present in the column is less than 2, then that percentage won't be visible in the pie chart. If it is greater than 2, then it will be visible with up to 2 decimals. That's what I have done here. So you can see that if x greater than 2, then 2 digit rounding to x value, else nothing. Then I am passing start angle equal to 60 so that the first wedge start from the 60 degree. Then I am taking out axis, then giving a title to each pie chart. At last I am showing all the pie chart. Here you can see this is the pie chart of class. So in pie chart of class we have two categories, one is edible, another is poisonous. So 51.8% are edible, 48.2% are poisonous. In cap shape we have these categories, and convex has the maximum percentage, that is 45. In cap structure we have 4 categories, one is scaly, another is smooth, other ones are fibrous and groups. the scale has the maximum percentage. Similarly, in cap color we have different colors name: brown, gray, red, yellow, etc. And the brown has highest percentage. Similarly, in braces we have no and braces. No has the highest percentage. And in pie chart of order we have different order values and none value is highest among all. Then in gill attachment we have free and attached values. The free is the highest one. Similarly, in gill spacing we have close and crowded. Close is the highest one. Similarly, in gill size we have broad and narrow. The broad is the highest one. Similarly, in gill color we have different color names. The buff is the highest one. Similarly, in stack shape we have tapering and enlarging. The tapering is the highest one. Similarly, in stack root we have bulbous, missing, equal, club and rooted. The bulbous is the highest one. Similarly, in stack surface above ring we have values like smooth, silky, fibrous and scaly. Smooth is the highest one. Similarly, in stack surface below ring we have smooth, silky, fibrous and scaly. Here also smooth is the highest one. Then we have stack color above ring. So here we have different color names and white is the highest color. Similarly, we have stack color below ring, veil type, veil color, ring number, ring type, spore print color, population and habitat. One thing you have to notice that the veil type doesn't have more than one category. It has only single category, that is partial. So whenever you build a machine learning or deep learning model, you should never consider this kind of single categorical column, because it does not impact more or does not helps the model to learn better. But in this case I am using this column as well, but when you try, please remove it. It won't helps the model to train better. After that, I am converting all the columns to the data type string using max CSV dataset. I am converting the CSV file to a dataset, and inside that method we have to pass the file path, the batch size, the label name, shuffle buffer size, shuffle seed, whether to do shuffling or not, and number of epochs. So the first one is the file path, that is mushroom.csv, and the second one is batch size. I have given 32, so there will be in each batch we will have 32 elements or examples, and our target label is class, that's why label name is class here. Then I have given shuffle buffer size, that is length of df, and shuffle seed equal to 42. This is an integer value, you can give any integer value, and if you want the same result as me, you should have this 42 value, and it will reproduce the same data sets if you rerun this cell. And I am keeping shuffle equal to true. to shuffle down the dataset, and the important one, that is number of epochs equal to 1. This is the number of times the dataset will be created. If you won't give any value to number of epochs, the default value is none, and if the value becomes none, then the dataset will be created infinite times. So better remember this parameter or this argument number of epochs and keep it or pass it 1, so that the dataset will be created only once. Let's run this. Yes, dataset is created. Then I am dividing the dataset into two parts, trained DS and valid DS. So reserving 80% of the data for trained DS and remaining 20% for valid DS. So I am using this take method for taking out the 80% of the data and saving that in trained DS, and skipping those data and saving that in valid DS. Let's run it. After that, I am configuring feature space. Feature space is to transform the raw data into encoded version. So as all the columns are categorical and string type, that's why I'm using string categorical to all except whale type, because this has only single value, and I'm passing number of OOB indices equal to 0, that is number of out of vocabulary indices. So the vocabulary is nothing but the unique elements present in the column. If the model encounters any other element other than unique elements of the column, then it should raise an error. That's why I'm passing number of OOB indices equal to 0. I hope you understood. After that, I am concatenating all the encoded features. So this is how feature space will be configured. So let's run this. Then as the level has two categories, that is poisonous and edible, we have to anchor the level. To anchor the level, I am using string lookup layer, which takes a vocabulary and number of OOB indices and output mode. So this is the vocabulary which will be used by the model, and when we pass the number of OOB indices equal to 0, then if any other element other than vocabulary will comes, then it will raise an error and it will return an integer value to each value. So poisonous becomes 0 and edible becomes 1. Let's run this. After that, I am adapting the feature space. To adapt the feature space, we should have only training examples without labels. Therefore, at first I am taking out the labels from the trained DS and saving that in the variable trained DS with no labels. Then passing that to the adapt method applied to the feature space variable, which will adapt the feature space. So let's execute this cell. After that, I am pre-processing the datasets and prefetching the dataset. So to pre-process and pre-fetch we have different methods. So for pre-processing I'm using map method applied to the dataset, and inside the map method I am passing a lambda function with two things or two parameters, x and y. X is the raw input and y is the level. So I am passing x to the feature space and y to the level encoder and returning the output, and then I am setting an argument number of parallel calls equal to tf.data.autotune. This argument mainly use it to go for distributed parallel processing, and then I have applied prefetch, and inside the prefetch I have done tf.data.autotune. It is for prefetching the dataset of n plus 1 epoch, while nth epoch is executing. Again repeating, prefetch is done to prefetch the dataset of n plus 1th epoch in the nth epoch, which will save the time. So doing both pre-processing and prefetching to both the dataset and saving that in their respective variables. Let's run this. After that I am checking the shape of the pre-processed data and also the shape of levels in a single batch. So here you can see after pre-processing we have 120 inputs in a batch of 32 elements, and levels are also batched into a size of 32. After that I am building a simple model. So feature space provides two methods, get inputs and also get encoded features. When we apply this to the adapted feature space, it will return raw inputs and encoded inputs respectively. So I am saving that in these two variables. Then I am creating a neural network architecture in which the first layer is a dense layer with 128 units and has ReLU activation, which takes encoded inputs and its output is saved in the variable x. After that layer I have another dense layer with 64 units and has ReLU activation and taking the output of the previous layer and generating this output x. Then I have a dropout layer where 50% of output of previous layer is dropped, and this is the input that I have given to this dropout layer and its output is saved in x. The last layer is also another dense layer with a single unit and sigmoid activation function. I have passed the output of the previous layer to it and saved its output in the variable outputs. Then using the functional API model from keras, I am creating the model and saving that in the model variable, and here in inputs of the functional API model I passed the encoded inputs and in outputs I passed the output of the last layer. After that I am compiling the model using Adam optimizer binary cross entropy loss and accuracy metrics. So remember that as this problem is a binary problem, that's why I'm passing binary cross entropy as a loss. If the output or number of classes is more than 2, you have to pass categorical cross entropy or sparse categorical cross entropy based on whether the outputs are encoded into one hot or integers. So let's run this cell. After that, I am training the model using the fit method, where I have passed the pre-processed to train dataset, and in validation data I have passed pre-processed valids, and I'm going for 25 number of epochs and saving the history in the hist variable. Let's run this and train the model. Yes, first epoch is completed and some warning is shown. Ignore the warning for now. So you can see we have accuracy 1 and loss is nearly 0. So after 25 epochs we have 1 or 100% training accuracy and nearly 0 training loss. So model is successfully trained. After that, to create the inference model with raw inputs, as all users wants to provide the raw inputs, that's why I am creating another model, that is inference model. So in inference model, just we need to pass the raw inputs and the outputs of the previous model, and you don't need to train it again as the layers are already trained. Let's run this and create an inference model. Yes, we have created successfully an inference model. Now let's check whether the model is predicting poisonous or edible for a random sample in the data frame. So at first I am dropping the column class from the data frame and taking out a random sample and creating its dictionary and saving that in the sample variable. Then after that I am converting it to tensor, then passing to the predict method of inference model, and if prediction is less than 0.5 I am returning poisonous, and if it is greater than 0.5 I am returning edible. I have done this less than 0.5 because the last layer has the activation function sigmoid. Its range is between 0 and 1. That is the reason to create this if conditional loop or block. Let's run this cell. So it returned a warning, please ignore that. So you see here it is showing it is edible. Let's run it again. It is showing now poisonous. So the model is working as we expect. After that I am saving the model with the file path or file name model.keras using the save method applied to the model. Model is successfully saved. Let's check whether this saved model works perfectly as we expect or not. That's why I'm reloading the model using this path or file name and saving that in the variable model. Then this is the sample that I have created by my own, and converting the sample values to tensor using this method and passing that to the predict function applied to the inference model. So see here, it returned poisonous. So successfully we have created the model. Thank you very much. The first part is over. Wait for the second part. Welcome for second part of the project, mushroom classifier. So here we will create an interface where users interact with the deep learning model and see whether the mushroom is edible or poisonous. So let's start. At first I have imported libraries like pandas, streamlit, tensorflow, and from tensorflow I have imported keras. Pandas for data manipulation, streamlit for creating the user interface, tensorflow and keras for working with the model that we have created. Then I have loaded the model using the file path this and save that in the variable model. Then loaded the data frame into this variable. Then I have created an user interface in which at first it has a title, and in title we have two things, one is image, another is a title. So for title I have created a container, and inside the container I have created two columns with different width sizes and vertical alignment equal to center, so that the contents inside the columns will start from the center. So under the image call I have an image, and to create image we have image method in streamlit where we have to pass the file path, and I am setting the width of the image to 150. Under the title call we have two write methods, one for the title eat or eat. So here is the description, that is eat or eat is a deep learning classification model which detects a mushroom whether the mushroom is edible or poisonous. After that, for output I have created a container with border and saved that in the variable out, and inside that container I have created 4 columns, calling them call 1, call 2, call 3 and call 4. Then I have created a method output where I am passing the prediction of the model, and if the prediction is less than 0.5 I am creating 4 images in these 4 columns and also a text, that is poisonous mushroom. And if the prediction is greater than 0.5 then I am creating 4 different images in this column and showing edible mushroom. Then I am returning the whole container out. Then for inputs I have created a container, and inside the container I have created 22 columns from input 1, input 2, input 3 to input 22, and for each input column I have created a variable for the select box, and inside that select box I have passed the label, that is the name of the column and the options available in the column. So to get the options I am going with unique method applied to the column. So doing same for each column available in the data frame or required to the model. After doing that for all the columns, I am creating a sample. So one thing to remember is that whenever you create a sample, make sure that the values are lists, or the values should be list of values. You should remember this important point while building a machine learning or deep learning project. Then I am creating an input dict, that is nothing but converting the sample to tensor and passing that input dict to the predict method of the model, and its output is saved in the prediction variable. As already I have explained that we have an output method which takes prediction parameter or argument. So after, you can see here, this is the output method, where if the prediction is less than 0.5 it will return this, if prediction is greater than 0.5 it will return this. Then I have created another container for sharing the contents. I have created 5 different width size columns with these column names, and inside each column I have created a link button or a simple button, and inside all the buttons I passed labels, icons, URLs and help parameters. So the MEDI call is disabled for right now and it will be enabled very soon, and this is nothing but my personal page. I will enable it very soon. Yes, the user interface is successfully created. Let's run this and see what is the user interface that we get. So to run this application file, open the terminal. To open the terminal in the VS Code, press Ctrl plus tilt, and if you see anything like this, you can clear it by passing the command clear. Yes, the terminal is cleared now. To run the application file, first you have to go to the directory where the application file is located. In my case it is new folder, so I am in correct directory. So after going to the directory, enter streamlit, run, and the application file name. In my case I have app.py. After this, hit enter. So it will go to the default browser. Yes, the application file is running. Wait for a while, it won't take much time. Yes, we got. With these values the output is poisonous. You can see this is the user interface. Here we have eat or eat with these icons. One is to take, another one is to drop. So you can see the description. Eat or eat is a deep learning classification model which detects a mushroom whether the mushroom is edible or poisonous. Wow, Then I have the output column with 4 images and with the text poisonous mushroom, and these are the input values. You can see we have in capsef we have convex, bull, sunken, flat, knobbed and conical. When we select the input, it is changing the output. You observe here it is showing running. So by changing different values, yes, when we have conical cap shape and fibrous cap surface, with these values it is giving poisonous mushroom. Let's change the cap color to white. It is poisonous. Let's change the bruises to no. Still it is poisonous. Let's change it to fall order. Still it is poisonous. Let's change the gill attached to attached. Still it is poisonous. Let's change it to crowded. Still it is poisonous mushroom. Let's change it to broad, the gill size. Yes, the mushroom becomes edible mushroom. So when we have cap shape equal to conical, cap surface is fibrous, cap color is white, bruises is no, order is fall, attached and crowded and also broad gill size with other specification, these we are getting edible mushroom. Let's change the grill color to brown. Still it is edible. Let's change it to gray. It is edible. Let's change it to chocolate. It is edible. Let's change the stalk shape to tapering. Still it is edible. Let's change the root to bulbous. Yes, it is changing to poisonous mushroom. Let's change it to club. It is becoming edible mushroom. Let's change it to rooted. It is edible. Let's change it to missing. It is edible. So club means edible, bulbous means poisonous. Let's keep it bulbous. Let's change the above ring surface to fibrous, and below ring to scaly. Still it is poisonous. Let's change the color above ring to red and below ring to yellow. Whale type, whale type has only single value, so we can't change it. Let's go with yellow whale color. Still it is poisonous. Let's go with 2 ring numbers, poisonous. Let's change the ring type to flaring. Now it becoming edible mushroom. Let's change this spore print color to green. It is becoming poisonous. If it is orange, it is edible. If it is purple, it is edible. If it is black, still it is edible. If it is chocolate, it is becoming poisonous. Let's change the population to several. It is poisonous. Let's change the population to numerous. It is edible. You can see the habitat also. You can go for waste. It is becoming edible. So in this way, this model can be used to see whether the mushroom is edible or poisonous based on the features available in the mushroom. So thank you very much for patiently listening me, and be successful in your life doing more number of projects and more number of artificial intelligent applications. Thank you very much.